I'd like to talk today about the rest of 7-1. So if you could please hit your paper 7-1 part 2, solving for a leg. When we worked on Pythagorean theorem the last time, we only solved for the hypotenuse. So today we are going to be solving for a leg. And I'd like to make sure that you understand where exactly you find a leg. So the first thing on your paper, I would like us to draw a right triangle. Mine's not perfect. I didn't use a ruler or a straight edge tool. Now in our right triangle, we need to make sure we have the right angle, because that right angle box is how we know this is for Pythagorean theorem. Let's identify the hypotenuse. My hypotenuse is always opposite or across from the right angle. And then the legs meet to form the right angle. Now your legs are interchangeable. They're A and they're B, but it doesn't matter which is which. But your hypotenuse is not interchangeable. Your hypotenuse has to be C. That is like the only thing that it could be. And in your theorem, it has to be alone. So let's look at how we can take what we know about right triangles and their legs and hypotenuse, and let's see how we can solve for a leg. This is the same learning target and standard that we worked on last time. This time we're focusing on the very last part of the learning target. Students will be able to use the Pythagorean theorem to find the length of a leg of a right triangle. So this is the part that we're working on today. We will be, instead of finding the hypotenuse, finding a leg in a right triangle. Here's example number 1. If you'll number it number 1 on your paper. We have a right triangle. I know that it's a right triangle because it has the right triangle box. I also know my hypotenuse is going to be opposite or across from that box. So when I use my Pythagorean theorem to find this missing side measure, I know that my C squared is going to be 29. Now I have one leg. However, I'm missing this leg. It doesn't matter if I want to call that A or B. That part is not important. The only thing that's really important in my theorem is that this 29 that's opposite or across from the right angle, it has to be in place of your hypotenuse. So I'm going to go ahead and I'm going to say that we're solving for A. Okay, so I have filled in my theorem. I have left A blank because I do not know that leg. I have filled in 20 for B. I know it's a leg because it helps form this right angle. And I've subbed in 29 for C. I know it's the hypotenuse because it's opposite or across from the right angle. So I'm going to square my values. So I have A squared plus 400. 20 squared, or 20 times 20 is 400. And then 29 squared, or 29 times 29 is 841. Now this step is new. We squared values last time. Then we were able to take the square root. However, this time I'm not. I have this 400 over here with my variable, A squared. I need to move that over the equal sign. So I'd like you to think equations. You solved a lot of equations last year. How do you get a value away from a variable in an equation? I hope you said you do the inverse. Inverse is a big word we worked on last year. So I'm going to subtract the 400 from both sides. So the A squared comes down. Those 400s cancel. 841 minus 400 is 441. Now I'm back to where I know how to solve. I have a squared, but I only need one a. So I'm going to take the square root of 441. And what that gives me is that a is 21. Now I can substitute. I can say, okay, is this true? In order to substitute, I'm going to fill in my variables like last time and see does it work. I've said 21 is a. So I'm going to use my Pythagorean theorem. And I'm going to ask myself, does 21 squared plus 20 squared equal 29 squared? Well, I know that 29 squared is 841. I found that over here in my work. So now I need to know what is 21 squared plus 20 squared. That is also, if I put that in my calculator, 841. So that means I've gotten it correct. I have just proven that the Pythagorean theorem works, and this is a right triangle, because when I square and add my legs, they equal the hypotenuse squared. So the new step. The new step is this subtraction part. This part right here is the new step. I did not do that step last time. That is the only difference in solving for a leg and solving for the hypotenuse, is that one subtraction step. Here's another example. This example is a word problem. I encourage you, if you have a word problem, to draw a picture. A right triangle. So I'm going to draw my triangle. Doesn't have to be perfect. Has a hypotenuse with a length of 32 meters. I know my hypotenuse is across from the right angle, so 32 meters. It has one leg with a length of 18 meters, so either leg. What is the length of the other leg? Express your answer as a square root. So that's different. Let's solve and then we'll talk about what that means. Express your answer as a square root. I'm going to use the Pythagorean theorem to solve because it is a right triangle. So I have a squared plus b squared equals c squared. I'm going to solve again for a. I don't know a. For b squared, I'm going to substitute in 18. I know 18 is a leg. It told me in the problem it has one leg with a length of 18 meters. It also told me the hypotenuse is 32. So I didn't necessarily have to draw the picture, but I like to see it. Okay, I'm going to square my values. 18 squared, or 18 times 18 is 324. And 32 squared, or 32 times 32 is 1,024. Now this is my new step. I need to subtract this value, or inverse this value away from a in order to solve. So a squared equals 700. Okay, and then to get 1a, I'm going to take the square root of 700. I just said square root. My question said express your answer as a square root. So I can put that the answer is the square root of 700. That's what the question was asking me for. Now, if I want this as a decimal, I also can find the square root of 700. I get a decimal, so I know it's not a perfect square. I'm going to do nearest hundredth. 4, 5, 7. The 7 says the 5 is going to round up. So I did find my answer as a square root. It is the square root of 700. If I want it as a decimal, I have rounded this decimal because it's not a perfect square to 26.46. The 7 makes the 5 round up a digit. And then if I want to substitute it in to check it, I can. Here's example number 3. A support shelf is in the shape of a right triangle, so there's already a triangle drawn for us, with a leg of 7 and a hypotenuse of 15. What is the length of the other leg to the nearest tenth? Since this already says nearest tenth, I know that it's not going to be a perfect square. I know it's going to be a decimal, but they've told me what to round to. They've also went ahead and labeled this leg as b. So I'm going to use my Pythagorean theorem. A squared plus b squared equals c squared. If this is b and these two form the right angle, I know that this has to be a, and this is my hypotenuse. This is my c. So a is 7, b is missing, and c is 15. So I'm going to square my values. 7 squared, or 7 times 7, is 49, plus b squared equals 15 squared, or 15 times 15 is 225. Okay, this is my new step. In order to be able to solve for b, I'm going to have to subtract this leg away from the leg that I'm missing in order to solve. Those cancel. That was my purpose of doing the inverse operation, to cancel those. B squared equals 225 minus 49, 176. And to go from b squared to 1b, I take the square root. And my directions ask me to round to the nearest tenth. So I know that this is not a perfect square. What I get is 13.26. And I just cut the rest of it off because I'm looking at the nearest tenth. So the 2 is in the tenths place. The 6 says the 2 rounds up to a 3. Now I can look at this and see, does that seem reasonable for B to be 13.3 inches? I know the hypotenuse is the longest side, and 15 is longer than 13.3. I also can substitute in. I do have to remember though, if I substitute in 13.3, it's not going to give me exactly 15 because I rounded that. This was not a perfect square, and I rounded that decimal, that very, very long decimal. I rounded it to the nearest tenth of an inch. So it's going to give me close, but not exact. Example 4 is your last example. An 8-foot wire extends from the top of a 5-foot post to the ground. Okay, so let's see. I'm going to draw my picture. I have my grass. In my grass, I have this post. This post is 5 foot tall. There is a wire that extends from the top of the post to the ground. Maybe it's a support wire. Maybe it is like a lighting wire. I don't really know. But let's draw that support wire. That's going to be important in our calculations. So here's my support wire. It tells me that this wire is 8 foot. To the nearest tenth, so I also know this is not going to be a perfect square. It would not need to be the nearest tenth if it was. What is the distance? So this is my question. From the bottom of the post, which is here, to the point where the wire meets the ground, which is here. So this forms a right angle here, making this my hypotenuse. And this is a missing leg because it forms that right angle. Now you don't have to necessarily draw a picture. I am just somebody, I need to see what's going on. So I like having this little picture. It didn't take me a second. I put my measurements where they needed to go. I have found that when you're solving for a leg, without a picture, sometimes students will quickly just say 8 squared plus 5 squared and go from there. And that would have made this incorrect because I'm solving for a leg and not a hypotenuse. So I'm going to use my theorem. A squared plus B squared equals C squared. I'm going to say A is missing, B is 5, and C, my hypotenuse, is 8. I am going to square my values. 5 squared, or 5 times 5 is 25. 8 squared, or 8 times 8 is 64. Okay, this is my new step. This is my unusual, I didn't have to do it last time, but I have to do it this time step. I need to move this 25, or inverse this 25, away from my variable. I need to take it to the other side of the equation so that I can figure out what that missing leg is. So I'm going to subtract 64 minus 25 gives me 39. And then to go from A squared to A, I'm going to take the square root of 39. And I've been asked to round to the nearest tenth. So when I take the square root of 39, which I know is not a perfect square, I get 6.24. Now the nearest tenth is my 2, and the 4 says it stays the same. So my answer here for my missing leg is the square root of 39, or to the nearest tenth, 6.2. I need to understand that those values are the same. 6.2 is the square root of 39. So that is how to solve for a leg in a right triangle using the Pythagorean theorem.